name is My name is
Hello everyone. Today our topic is about centripetal force. So, what is centripetal force? For a body in a circular motion, a force acts on the body in a direction towards the center of the circle. This force is called as centripetal force. A centripetal force is always perpendicular to an object's motion and points towards the center of the circle. In addition, tangential velocity is defined as the component of the velocity of an object at a given point in time that acts in a direction that is tangential to the circle. In a circular motion, the tangential velocity vector is consistently changing its direction. Since the tangential velocity is changing, that means there has an acceleration. Based on Newton's second law, where there is acceleration, there must be a net force that causes it. In a circular motion, the net force on the object is called the centripetal force. Looking at this slide, this is the formula of centripetal force. The examples of centripetal force are the Earth orbiting around the Sun, spinning a ball on a string, and the roller coaster. There are three factors that affect the centripetal force. The magnitude of the centripetal force depends on the mass of the body, the linear speed, which is also known as tangential velocity, and the radius of the circle. The linear speed in the centripetal force will show how fast a body moves in a circular motion. Centripetal force increases if the object moves faster, which means increasing the velocity, the mass of object is increased, and the radius of the circle is decreased. These are the steps of the centripetal force model set out. Firstly, make a hole on the table tennis ball. Then, insert the string into the hole of the table tennis ball. Next, glue the string with the table tennis ball. After that, cut both ends of the straw. And then, insert the string into the straw. Last but not least, tie the straw to the slotted weight.
Imagine the table tennis ball is the Earth and the straw is the Sun. The Earth is held by a centripetal force by the Sun, so that the Sun can be surrounded by the Earth. The floated weight in the setup has the function of affecting the acceleration. As the mass increases, the acceleration decreases.
Not only that, but there are also some theories behind the centripetal force model set out. The magnitude of the centripetal force depends on the radius of the circle. The smaller the radius of curvature, the larger the centripetal force. The setup also applies Newton's second law of motion. When the setup spins vertically, the setup needs to spin at a constant angular velocity. It shows centripetal acceleration needs at every time will be the same. Besides, an object moves in a circular path based on the center of the circle.